This is a study note of machine learning with Python. Welcome to my channel. Okay, let's open the project folder with the Visual Studio Code. Create a new file ml002 preprocessing.py. So we will talk about data preprocessing, and we will do the following items. The first one is binarization. The second, we will talk about how to handle missing value, the null value or the NaN in Python. NaN means not a number. Then we will talk about how to standardize the data. Some people call this normalization, and some people call it standardization. The following we will talk about how to handle categorical variables. There are two kinds of categorical variable. One is ordinal. The other is nominal categorical variables. Then we will talk about one hot encoding method in taking care of the categorical variables. Finally, we will talk about the multi-collinearity problem when we're doing the data preprocessing, especially when doing the one hot encoding. Okay, binarization. Binarization is a way to transform the data from a set of numerical values into a binary number such as 0 and 1. Let's create an example, then practice how to binarize the data. From sklearn, import preprocessing. Also import numpy as np. Let's create an array and call it non-binary. Then randomly populate some numerical values in the array. And randomly make some value positive and some negative. Okay, print non-binary. Print it out and take a look. So far so good. Now create a variable called binarized equal to preprocessing and use the binarize function to transform our data, then set the threshold equal to 0. Let's print out the binarized data and take a look. All the positive numbers are converted to 1 and negatives converted to 0. Alternatively, we can use the preprocessing binarizer function to achieve the same result with a different syntax. Here we put a threshold setting in the binarizer function and use its transform function to transform the data. Let's print it out and take a look. It shows exactly the same results. Okay, that was binarization data transformation functions. When do we need to use these functions? Maybe when we want to simplify our data values. Let's comment out some of our program codes here and prepare the data for our next section, how to handle missing values. Let's copy this non-binary data array and make some modification for the missing value. Let's make the 0 on the 0 into a np.nan, a missing value. And rename the variable into has nan. Print it out and take a look. The data has a missing value nan in it. Let's print it out with np.isNaN function. If we try to sum up this array, we will get an NaN. Therefore, to sum up an array with missing values, we need to use mp.nan sum. Let's import pandas as PD. Convert our dataset into a PD data frame. Data frame provide a few features that help us remove columns or records. Now print out the data as a data frame. One of the methods to handle the missing values is to drop the record with missing values. A function provided by the data frame. However, when we have very limited amount of records, dropping the records with missing value probably is not the best way to handle the data. In this situation, we should use the imputation method to handle the missing values. Imputation is a practice in statistics in which we replace the missing values with some other data, such as mean or medians. So let's enter from sklearn.impute import simple imputer and make our imputer equal to simple imputer with missing value equal to mp.nan and strategy equal to mean. Then enter imputer equal to imputer.fit and provide a dataset to impute the mean value. The dataset we provided here is the first column of our data frame where the missing value exists. The fit function will calculate the mean and the standard deviation from the available data to be used in the imputation. Now we can transform the data by using the transform function, and it will replace the missing value with its mean value. Let's print out the data frame, and we can see that the missing value has been replaced by the first column's mean. Let's simplify our process here. Actually, we can do fit and transform together, and the fit and transform can be applied to the whole data set. Okay, that was using imputation in handling the missing values. Now let's take a look at the standardization, or some people call it normalization. To standardize the data column means we convert our data into mean equal to 0 and standard deviation equal to 1. In practice, we need to standardize both the training and the testing data sets, and only use the transform method on the testing data, which means we don't fit the testing data, then transform it, which also means that the mean and standard deviation are based on the training data only. Okay, let's type from sklearn.preprocessing import standard scalar. Then filter equal to standard scalar parentheses dot fit x. X is our training data. By the way, let's continue using our imputed data x. So let's insert this line of code here. Now we can use filter.mean underscore and filter.var underscore to print out the mean and the variance of the training data. To simplify the process, we can use fit underscore transform, this function, to standardize the data directly. Or we can replace our fictor variable with a standard scalar function. Either way will work. Okay, let's comment out the line 80 and 81, then restore our fictor variable. I just like to demonstrate that if we have a testing data, then we should use this fictor variable to standardize our testing data. So why should we standardize our data? It is because the feature matrix usually have multiple columns of variables, and each variable is measured in different units and scales. Therefore, variables with bigger values are weighted more in the model. Therefore, we should standardize our data before we feed it into machine learning model. Okay, now let's talk about how to handle the categorical variables. We will use the usedcar.csv file that we downloaded from previous video. Therefore, dt equal to pd.readcsv, and the file name is usedcars.csv. So print out the first file record for review. We can see that model, color, and transmission are the categorical variables. There are two kinds of categorical variables. One is called ordinal, the other is called nominal categorical variables. Let's talk about the ordinal CVs first. Ordinal CV is a kind of data labels that can be sorted in a certain way. Since we don't have ordinal CV in this data set, we will use the year column and pretend that it is an ordinal CV. So let's type in from sklearn.preprocessing import label encoder. Now create an encoder variable to hold the label encoder function. Add a new column and name it year encoded to our data set. Then populate this column with encoder.fit_transform. The data source will be the first column, dt year.values. Let's print out the data and see how the label encoder transforms our data. Another example is if we have the car size available in small, medium, and large, then we can convert the data label into small equal to 1, medium equal to 2, and large equal to 3. Okay, now let's talk about the nominal categorical variables. The best and correct way to handle the nominal categorical variable is to convert them into a set of dummy variables. This process is usually called one-hot encoding, and we can use the getDummies function to achieve this conversion. Let's type dt_cat equal to pd.getDummies, and we will convert the model column of the data set. Let's print it out and take a look. We can see that dt_cat has 3 columns, represent the 3 car models in the data set, and each one has been converted into dummy variables. Actually, the pd.getDummies function is very smart. We can feed it the entire data set, and it will figure out which column are categorical variables and will convert it into dummy variables. Let's print out the column header of the new converted dataset. However, the one hard encoding method we demonstrated here will cause the multi-collinearity problem. Take the 3 model dummy variables as an example. Each row are summed up equal to 1, which means these 3 variables are not independent. When independent variables are highly correlated, in statistics we call this the multiple collinearity. Therefore, to avoid the multi-collinearity problem when convert categorical variables into dummy variables, we can drop the first dummy variable from the dataset. Therefore, in the getDummy function, we should set the drop first parameter equal to true. Maybe we can make a comparison by printing out the column headers. One is before dropping the first, and the other is after dropping first. Okay, these are how we pre-processing the data. If you like this video, please thumb up and subscribe. Thank you.